Hey everybody, Mrs. Bixler here, and we're going to start with a little inspiration from the 80s. This is a picture of the Miracle on Ice. This is when the United States hockey team in the Olympics upset the USSR or Russia. And it was a huge deal. And the announcer goes, "Do you believe in miracles?" Yes. And so I always like to think about that whenever I'm faced with something hard. So I want to say, yes, we can solve hard equations. Get ready to go. All right, draw this inspiration. Draw. Okay, on to the next slide. So we've seen a ton of different equations throughout our time in math, and we started really easy. So this is from 7th grade, right? We've got one little x, nothing's really happening to it, and all we want to do is just isolate that x. So I'm going to undo what's happening to it. So I'm first going to subtract 5 from both sides, and I'm left with x equals 25, and I'm done. Awesome, easy peasy. You should feel really good with that. And then we sauced things up a little bit. And instead of just being an x, we now made it an x squared. There's still only one of them, but we still want to isolate this guy. So we're going to subtract 5 again from both sides. And then you're left with x squared equaling 25. And then we talked about this in the fall. If we're trying to undo what's happening to x, I need to square root something that's being squared. So remember, anytime I'm square rooting something that's being squared, I'm left with the absolute value. And then I square root the other side. So I get that the absolute value of x equals 5. But I know that x can be two values. It can be positive or negative 5. And you're done. So things got a little bit harder, right? So now let's move on to the third type of equation. So this third equation, there is now an x squared term and an x term. So we've kind of combined those first two equations. The first one just had an x, the second one had an x squared. Now we've got both. So we've seen this before. Whenever we saw an x squared term, an x term, and nothing else, we had the zero product property. And we already, that's a little p. So we already have a zero, so we're good there. But now we need a product. So I don't see a product here. I see the sum of two things, but you should feel really comfortable now factoring. So we factor out, and we called it undistributing back in the fall, but we factored out an x, and then we're left with x plus 5 equaling 0. Awesome. Sorry for the delay in my pen. Weird. But now look, zero product property tells us I've got two things that are being multiplied together that are set equal to 0. So then I know either this one is equal to 0 or this guy is equal to 0. And if we solve both of these equations out, we wind up with x equaling 0, because we don't really have to solve the one on the left, or x equaling negative 5. And we're done. And you should feel super comfortable with that. So these first three equations, I want you to see what this progression is like. So the first one, we started out with just an x. The second one, we still had an x, then we squared it. And then in the third one, we had an x squared and an x. So hopefully this progression makes sense. So now we're going to turn it up another notch. Get ready and say to yourself, yes! Okay. So now we have a trinomial. We have an x squared term, an x term, and then something else. This is the exciting part, because if we just had the x squared term and the x term and nothing else, it would be ZPP. But this something else is exciting for us. Now, we have seen this before. What if we just had this and there was no equal sign? What would you do there? You would factor. So let's try it. What are factors of 4 that combine in some way to get us a 5? Well, 4 and 1. So I can write my little binomials here. So I get x plus 4, and x plus 1. Let me change that to a 4. Again, the pen delay is crushing me. All right, there we go. But now, look, we don't have it just as an expression. This is an equation. And we know that these guys all equal 0. So look what we've got. This is a super basic zero product property question. I've got two things that are set equal to 0. So either x plus 4 equals 0 or x plus 1 equals 0. So all that work that we did in the fall is now coming back to help us out. So I now know that x could equal -4 or -1. And you're done. Kind of cool, right? So the whole point of factoring is to get us that product. So then we can use the zero product property to solve. So that's the fourth type of equation. So what if I gave you a problem that looked like this? I want you to pause the video and try to do this on your own. Here's a hint. Factor was on the left-hand side first. Do it! Yes! Okay, so we're back. Hopefully the first thing you did is you said, I know I need to factor this because I see an x squared term, an x term, and something else. This something else is what's driving me to know that I need to factor. So first, I'm going to take out a 2, and I get x squared plus 12x plus 20, and I still have that equals 0 on the right-hand side. And then this is not enough, right? I still need to know what's happening here. So, let me see if I can factor this puppy. What are factors of 20 that combine in some way to get me a positive 12? Hopefully you figured this out and you did x plus 10 times x plus 2. Order does not matter. Don't forget that 2 in the front. Whoop, and it's set equal to 0. Now this 2 actually doesn't matter because if you're solving here, you can just divide it from both sides. So if I divide 2 on the left and I divide 2 on the right, it still just stays 0, right? So if I divide 2 on both sides, then all I've done is gotten rid of the 2. 0 divided by 2 is just still 2. So then I can go ahead and solve this guy. If I know that these two things multiplied together give me 0, I know that x plus 10 equals 0, or x plus 2 equals 0. That's the word or. So then I know that x is equal to -10 or -2. Amazing. So let's keep on with the factoring mindset here because we also saw problems that looked like this when we were factoring, right? So let's pretend this equal sign wasn't here. How would you attack this problem? And if I asked you to factor it, well, you'd say, wait a second, I think this is the difference of two squares because x squared is a perfect square and 81 is a perfect square. So this simplifies, factors, sorry, x minus 9 times x plus 9. And since this is not just an expression, but this is actually an equation, so let me get rid of that little scribs, this is still equal to 0. So then look, this is zero product property. So I know that x has to be positive 9 or x equals -9. But I have a little trick for you. This problem is actually just like problem number 2. Because do you see how they both have just this x squared alone? Now this one on the previous slide looked like this. So the only way they differ is that the guy on the bottom has a 0 over there, but you're still doing the same thing. You're still isolating that x. So watch. If I add 81 to both sides as opposed to factoring it, look what happens. I get x squared equals 81. Oh my goodness. If I take the square root of what's on the left, I get the absolute value of x. And then I take the square root of 81. Look, x still equals positive or -9, which is what we got on the previous slide when we factored. So it actually doesn't matter which way you do it when you have a difference of two squares situation. Cool? All right, so that is sort of the general progression here. Now remember, we started with just a plain old x, and all we had to do was isolate it and subtract 5 from both sides. Then we added in a little x squared. We still had to isolate it, but then we had to square root both sides. Then we got to a point where we had x squared and x. And here is when we had ZPP. So we had to factor and then solve. And the same thing is true here. I've got an x squared term, an x term, and then this something else. I need to factor this and then get it to look like zero product property. two things being multiplied together, those little binomials that we've been working on for the last 5 days, and then we can solve for x. So hopefully this all made sense. Go ahead and rewind and watch whatever you need to watch again and go tackle that worksheet. You can do it. Yes, I believe in miracles. All right, see you guys soon. Thanks.